Welcome to another episode of AP Computer Science. Be ready to take notes and learn much. Java provides a structured approach for dealing with errors that occur when running a program. This is referred to exception handling. The word exception is meant to be more general than error. Exception handling is used to keep a program running, even though an error is encountered that would normally stop the program. The programmer can choose to ignore the exception, fix the problem, and continue processing, or abort the execution of the code. An error is when a program does not do what it is intended to do. Compile time error occurs when the code entered in the computer is not valid. Logic errors are when all the code compiles correctly, but the logic behind the code is flawed. A runtime error is a problem that the compiler was unable to detect before the execution of the program. Java provides a way for a program to detect an exception has occurred and execute statements that are designed to deal with the problem. This process is called exception handling. If you do not deal with the exception, the program will crash and burn. Then send an exception message to the console. Common exceptions include arithmetic exception, null pointer exception, array index out of bounds exception, class cast exception, and IO exception. There are three ways of handling a thrown exception. In some cases, such as when there is a possibility that a divide by zero exception might occur, the programmer has the option of not dealing with the exception at all. This can be useful in situations where the programmer has already taken steps to ensure that a denominator will never become zero. The programmer also might attempt to fix the problem or skip over the problem. To do either of these, the programmer needs to catch any exception that may be thrown. To catch an exception, one must anticipate where the exception might occur and enclose that code in a try block. A try block is followed by a catch block that catches the exception and performs the desired action. The general form of a try-catch statement. The try block tries the code that might throw an exception. If no exception is thrown, the code within the try block is executed. Once the exception is thrown, however, all code following the exception in the try block is skipped. The catch block refers to the statements that executes if the exception is thrown. A try block can be followed by more than one catch block. When an exception is thrown inside of a try block, the first exception type matching the catch block will handle the exception. The exception type specifies what kind of exception object the catch block should handle. This can be specific or it can be general. The exception by itself will catch any exception that comes its way. Identifier is an arbitrary variable name used to refer to the exception type object. Any operations done to the exception object in the method's call will be used as identifier. Here is an example of a try-catch. The value of the denominator is 0, so an arithmetic exception will be thrown whenever the numerator is divided by the denominator. The catch block will catch the exception and print the error message. A print line statement in the try block will not be executed because the exception occurs before the program reaches that line of code. Once an exception is encountered, the rest of the lines of code in the try block will be ignored. The value of the denominator is not 0. If the value of the denominator is not 0, the code in the catch block will be ignored, and the print line statement will output the rest of the division. Either way, the program continues executing at the next statement after the catch block. There are times when it makes sense for a program to deliberately throw an exception. This is the case when a program discovers some sort of exception or error condition, but there is no reasonable way to handle the error at the point where the problem is discovered. The program can throw an exception and hope that some other part of the program will catch and handle the exception. An if statement is usually used to throw an exception. For example, the following statement throws an arithmetic exception. The exception object is created when the new operator right in the throw statement. Exception classes in Java have a default constructor that takes no arguments and a constructor that takes a single string argument. Reading textual data from a file is very similar in many ways to reading input from the keyboard. The scanner class and all of its methods remain the same. However, you must import the classes java.io.file and java.io.ioException. The java.io.file is a holder class that can take a string representing the path of a file on your computer. Creating a scanner object that reads from a file is simple. The first line assumes that there is a file named test.txt in the folder where you run your Java files. The second line shows an example of creating a file object in its own line of code. That also shows the file being created with a full path to the file. It would be used if your text file was not in the same directory as your Java files. But what happens when the file you're looking for doesn't exist or has other status that prevents it from being read? You guessed it, an exception is thrown. Scanner will take no responsibility in handling the exception, so every time you want to use the scanner with a file, you have to use a try-catch block. When reading a large amount of data from a file, it is often useful to know whether there is any more data in the file to be read. Reading from a file which has no more data will give you a no such element exception and stop your program. The scanner class has several methods for determining if there are any more data in the file to be read. Has next double, and an upside down exclamation point will be methods most useful for you. If there is anything still to come, has next will return true, while has next double will only return true if a valid double is next, and has next int will only return true if there is an int value is next. Using a simple while loop, you can easily read data until the end of the file. Creating your own files is a bit trickier than reading from them. There are two basic ways to write data to files. Raw byte writing is useful for items such as pictures. Character streams are useful for writing plain text. There are two basic constructors. The first constructor opens a basic file writer object and points at the file tests.txt in the same directory where the Java files are being run. When this file is opened and written to, all the data that was previously stored in the file will be erased. The second constructor indicates that the new data being sent to the file will be appended to the end of the file. In either case, if the file does not exist, then Java will attempt to create a new file with the indicated name at the indicated location. Writing data to a file is done by using the filewriter.write method. The string is the data that will be written to the file. The first int is where to start writing data in the string. The second int indicates how many characters of the string to actually write. This will only write hello to the file test.txt. Merely opening a file and writing to it is not enough to store your data in most cases. You know from personal experience that if you do not save your work in a word processor, your work will not be there the next time you start your computer. Data must be saved. This is done with FileWriter by calling the close method when you are done writing data. This closes the output stream of the file and saves your data. There is no equivalent to print line with the FileWriter class, so any new lines that you wish to create must be done with the new line character. FileWriter only deals with writing strings to text files, which creates a bit of a problem when writing numerical data. However, we can use strings to change our other data types. FileWriter requires you to specify how many characters a given string to print out. If the int value you send is bigger than the string itself, you'll get a string index out of bounds exception when the FileWriter object tries to access characters in a string which do not exist. An easy way to prevent this from occurring is to always create a string object before the write method is called with the data you wish to output, and use the strings length method for how many characters to print.